Now we move on to skeletal muscle growth anatomy. The tendon is connective tissue that covers the outside of our muscle. Outer muscle, outer muscle we have is called the epimysium, and it's continuous with the tendon. It helps protect our muscles so it doesn't shear against the bone. Another bit of connective tissue inside the epimysium is the perimysium, and that covers the subunits of muscle which are called the fascicle. Inside the fascicle you will find the endomysium, which covers individual muscle cells. Those muscle cells are called myofibers. Myofibers are bumpy due to nuclei on the outskirts of them. They sit just underneath the sacroilium. Myofibrils are inside the myofibers and have striations on them. There are 6 muscle roles. The first one is synergist. The synergist is a movement in the muscle that stabilizes the joint around the movement, around which movement is occurring, which in turn helps the agonist function effectively. Synergist muscles also help create the movement. Synergist muscles are muscles that assist other muscles to accomplish a movement. The chest, triceps and shoulder work together to do a push-up. The biceps and your back muscles work together during a pull-up to pull your body to the bar. The second muscle role is agonist. The agonist in a movement is the muscle that provides the major force to complete the movement. Because of this, the agonist is known as the prime mover. In the bicep curl, which produces flexion of the elbow, the biceps is the agonist. Moving on to antagonist. The antagonist and agonist muscles often occur in pairs, called antagonistic pairs. As one muscle contracts, the other relaxes. An example of an antagonistic pair is the bicep brachii and the tricep brachii. To contract, the tricep brachii relaxes while the bicep brachii contracts to lift the arm. Antagonistic muscles are simply the muscles that produce an opposing joint torque to the agonist muscles. This torque can aid in controlling the motion. The opposing torque can slow movement down, especially in the case of ballistic movement. Moving on to stabilizer muscles, they are tasked with stabilizing the body, while primary movers are the muscles doing most of the work. Primary movers are moving the load, and they will be the muscles you feel most during the exercise. Pecs, lats, quads, biceps, bicep brachii, tricep brachii, and shoulders. The stabilizers are the smaller muscles generally. Take the biggest muscles in an area, for instance the pecs, and strip them away and look at everything else that activates when you use them. Those are the stabilizing muscles. The fixator joint in a movement is the muscle that stabilizes the origin of the agonist, and the joint that the origin spans in order to help the agonist function most effectively. The origin of the muscle is the bone, typically proximal, which has a greater mass and is more stable during contraction than the muscle's insertion. For example, with the latissimus dorsi muscle, the origin site is the torso, and the insertion is the arm. In summary, skeletal muscles are attached to bones on each end by tendons. The origin is the fixed attachment, while the insertion moves with contraction. The action or particular movement of a muscle can be described relative to the joint or the body part moved. There are 650 muscles in the body. We have narrowed them down to 60. There are many antagonistic pairs in the body. A few of them are the bicep brachii and the tricep brachii, the back or the latissimus dorsi, and the chest, or your pectoralis major, your abdominals and your sacrospinals, your quadriceps and your hamstrings, and your tibialis anterior, or your shin, and your gastrocnemius. Here we have a front-facing photo of all the muscles in the body, and a back-facing photo of the muscles in the body. There are 16 muscles that make up the legs, a few of them being the gluteus medius, the gluteus maximus, the quadriceps, obviously the hamstrings, the tibialis anterior, the gastrocnemius, the rectus femoris, the extensor hallucis, and the gracilis. When the agonist of the shoulder joint is the anterior deltoid, the movement will be flexion, the origin will be clavicle and scapula, the insertion will be deltoid tuberosity of humerus, and the antagonist would be latissimus dorsi. When the agonist is posterior deltoid, the movement will be extension, the origin will be clavicle and scapula once again, the insertion will be humerus, the antagonist will be latissimus dorsi once again. When the agonist to the shoulder joint is the medial deltoid, the movement will be abduction, the origin will be clavicle, scapula, and acromion. The insertion will be humerus, and the antagonist will be latissimus dorsi. When the agonist is latissimus dorsi, the movement will be adduction, medial rotation, and extension. The origin will be the lumbar vertebrae, ilium, and the thoracic vertebrae. The insertion will be the humerus once more, and the antagonist will be deltoid. When the agonist is the rotator cuff muscles to the shoulder joint, the movement will be abduction, the origin will be scapular, the insertion will be humerus, the antagonist will be deltoid. When the agonist is pectoralis major finally, the movement will be medial rotation, origin will be ribs, sternum and clavicle, the insertion will be humerus once more, and the antagonist will be the latissimus dorsi. For the radial ulnar bones, the joint, when the agonist is supinatals, the movement will be supinate forearm, the origin will be lateral epicondyle of humerus, the insertion will be lateral proximal radial shaft, and the antagonist will be pronator teres. Obviously, when the agonist is pronator teres, the antagonist will be supinators for the pronator teres. The movement will be pronation of the forearm, origin will be medial subcondylar ridge of humerus, and the insertion will be middle of the lateral surface of the body of the radius. When the agonist at the bicep brachii, when the agonist at the elbow is the biceps brachii, the movement will be flexion, the origin will be the scapula, the insertion will be the radial tuberosity, and the antagonist will be the triceps brachii. Obviously, when the triceps brachii is the agonist to the elbow, the antagonist will be the biceps brachii, the movement will be extension, origin will be scapula, insertion will be olecranon process of the ulna. The knee joint, when the agonist to the knee joint is the hamstring, the antagonist will be the quadriceps. The movement will be flexion of the knee and extension of the hip. The origin will be tuberosity of the ischium. The insertion will be tibia and fibula. When the agonist is the quadriceps, obviously the hamstrings will be the antagonist. The movement of the quadriceps will be knee extension, hip flexion. The origin will be rectus femoris and vatus muscles, and the insertion will be tibial tuberosity. When the antagonist to the hip joint is the iliopsoas, the antagonist will be the gluteus maximus. The movement will be flexion. The origin will be lilac fossa and the lumbar spine. The insertion will be lesser trunchata of femur. The antagonist of the hip joint, when the antagonist of the hip joint is the gluteus maximus, it is obviously going to be the iliopsoas. The movement will be external rotation and extension. The origin will be the gluteal surface of ilium, lumbar fascia, sacrum, the sacrotuberous ligament, and the insertion would be the gluteal tuberosity of the femur and iliotibial tract. The antagonist is obviously the iliopsoas. When the antagonist is the gluteus medius and minimus, the movement will be abduction and adduction. The antagonist will be the adductors. Insertion will be greater trochanter of the femur, and the origin will be the gluteal surface of ilium under the gluteus maximus. When the antagonist is the adductors, it's obviously going to be the gluteus medius and minimus. The origin will be the pubis. The movement will be the adduction, and the insertion will be the femur and tibia. When the agonist is the tibialis anterior to the hip joint, the antagonist will be the gastrocnemius and soleus. The movement will be dorsiflexion. The origin will be the lateral surface of the tibia and the adjacent interosseous membrane. The insertion will be the medial cuneiform and the base of the first metatarsal bone of the foot. When the antagonist of the hip joint is the gastrocnemius and soleus, obviously it will be opposite to this one up here. So it will be tibialis anterior. The insertion will be the Achilles tendon. The origin of the hip joint would be the lateral condyle of femur and the medial condyle of femur, and the movement would be plantar flexion. Finally, the spine, when the internal obliques of the agonist of the spine, the movement will be epilateral trunk rotation and compresses abdomen, and the antagonist would be external obliques. The insertion will be pectineal line of pubis and ribs between 10 to 12. The origin will be the inguinal ligament, iliac crest, and the lumbodorsal fascia. When the antagonist of the spine is the external obliques, the antagonist will be internal obliques. The movement will be flexion of the torso. The origin would be from ribs 5 to 12, and the insertion would be the outer lips of the iliac crest, pubic tubercle, linea alba, inguinal ligament, anterior superior iliac spine. When the antagonist of the spine is the rectus abdominis, the antagonist would be the erector spine. The movement would be the flexion of the lumbar spine, the origin would be the crest of the pubis, and the insertion would be the costal cartilage of ribs 5 to 7. When the erector spinae is the agonist of the spine, the movement would be extends the vertebral column. The origin would be T9 to T12 of the thoracic vertebrae. Insertion would be T1 to T2 of the thoracic vertebrae, and the antagonist would be the rectus abdominis. There are 3 types of muscle fiber: slow oxidative, which is type 1, fast oxidative glycolytic, which is also known as type 2A, and fast glycolytic, which is known as type 2B. Type 1, or slow oxidative fibers, have structural elements that maximize their ability to generate ATP through aerobic metabolism. These fibers contain many more mitochondria than the glycolytic fibers, as aerobic metabolism, which uses oxygen in the metabolic pathway, occurs in the mitochondria. Athletes that run long distance, like Mo Farah, will have predominantly more slow twitch muscles, as they are the muscle fibers that last longer and do not fatigue as quickly as the other 2. Fast oxidative glycolytic fibers are fast twitch muscle fibers which have been converted via endurance training. These fibers are slightly larger in diameter, have more mitochondria as well as greater blood supply and more endurance than typical fast twitch fibers. Medium distance runners between 400 and 800 meters will tend to have predominantly these type 2 muscle fibers. David Rudisha holds the fastest 800 meter time, 1 minute 40 seconds, 0.91, and the 400 meter world record is held by Ade van Niekerk, running it in 44.52 seconds. The fast oxidative glycogenic muscles allow the 400 meter sprinter to sustain a fast pace for the whole race. However, they are not quite fast glycolytic, as they do not fatigue as fast. The 800 meter runner would have muscle fibers more towards the slow oxidative, as they are able to keep a fast pace for much longer. He will not be as fast as the 400 meter runner, but they are still running at great paces for the distance these athletes run. Fast glycolytic fibers, or type 2B, are white in colour due to a low level of myoglobin and also contain few mitochondria. They produce ATP at a slow rate by anaerobic metabolism and break it down very quickly. This results in short, fast bursts of power and rapid fatigue. They have a large diameter and possess large volumes of glycogen, which is used in glycolysis to generate ATP quickly. Usain Bolt has run the 100 meter sprint in 9.58 seconds. He also ran the 200 meter sprint in 19.91 seconds. The fast glycolytic muscles are what has helped him produce the short, fast bursts of power in the short amount of time that he runs. If he were to run much further distance, he would fatigue very quickly and would not be able to keep up with the other athletes running that race.